Alright, let's look at the practice exam 2, problem number 5. Alright, so for this rational function, f of x equals x over x squared plus 4, let's answer these questions. Alright, so part A, we want to find an open interval on which f is increasing. So we need to look at the first derivative. So f prime of x is equal to, right, so we have to use the quotient rule. Right, so square the bottom, so quantity x squared plus 4 squared, right, take the derivative of the top, which is 1, times the bottom, so x squared plus 4, right, quotient rule, so it's a minus, top guy, x, times derivative of the bottom, which is 2x, right, so you will get, let's see, 4 minus, so this is negative 2x squared, and this is a positive x squared, so negative x squared over, denominator is x squared plus 4 squared, right? So we can factor this out into 2 plus x times quantity 2 minus x all over quantity x squared plus 4 squared, right? So we're going to set that equal to 0. So we can find the two critical numbers. X is going to be equal to a negative 2 and a positive 2. So plus or minus 2. So those are our critical numbers, right? Then we can do a number line. So draw a number line, and then place negative 2 and a positive 2, right? Then we want to find out about the sign of f prime, right? So we can try any sample number. Let's say anything less than negative 2. So we'll try like negative 3. So f of negative 3. And between negative 2 and 2, so we try f prime of 0. Right here, we can look at the f prime of, say, positive 3. Alright, so if you plug in negative 3, so easy one is probably this one, right? So 4 minus negative 3 squared would be 4 minus 9, so that's negative. Denominator is always positive, so this is going to give us a negative value here, right? Then if you plug in 0 here, that's going to be 4, that's positive, so it's positive, and denominator is always positive, right? If you plug in positive 3, again, you're going to get a negative value, right? So we have negative here, positive here, and a negative there, right? So if you want increasing function, so interval of increasing, so here, derivative must be positive, so it's going to be between negative 2 and positive 2. Since they are looking for an open interval, so therefore we have f is increasing on open interval from negative 2 to positive 2. Right, so that's the answer for part A. Right, how about part B? We want to find an open interval on which f is concave upward, so we have to take the derivative again. Alright, so we look at the second derivative, f double prime of x. Right, so again, quotient rule. I will actually look at this one. Right, so maybe I'll just right, so I'm gonna look at this guy and then take the derivative, right? So again, quotient rule, square the bottom, so you have x squared plus 4 squared to squared, so it's a fourth power, right? Then derivative of the top is negative 2x, right, times the bottom, so which has x squared plus 4 squared, right, minus, right, the top guy is negative 4 minus x squared times the derivative of the bottom. So it's a 2 in front x squared plus 4 to the subtract 1 from the first power, then multiply by derivative inside, so 2x. Right? Then what we're going to do is we're going to pull out the common factors. So we have, first we have a 2x here and another 2x there. So I'm going to pull out 2x. Right? And we have, let's see, x squared plus 4, and there are actually two of those here, so I'm going to pull those out. X squared plus 4. Right? And I think that's about it. So I'm going to just collect the leftover terms. So there's a negative sign, so it's negative x squared minus 4. So just distribute the negative sign. So that will take care of that and that. Alright, then you have 2 times 4 times negative, so it's negative 8. Right? Then 2 times negative, negative positive, so it's a plus 2x squared. Right, then you have x squared plus 4 quantity to the 4th power. Right, then we can cancel x squared plus 4. There's one of them, so we can reduce 4 to 3. Right, then we can clean up a little bit more, so you have a 2x here. Alright, this is going to be combine 2x squared and the negative x squared, so it's an x squared and a minus 12. Right, so divided by x squared plus 4 cubed. Right, so let's set this guy equal to 0. Right, so you will see that you will get either 0 or plus or minus square root of 12. So this is going to give us x equals 0 or plus or minus square root of 12, which is going to be, let's say, square root of 12 is equivalent to 2 square root of 3. Right? Then we can do a number line here. So do a number line. Right? So we have to put the 3 different places. Here's a 0, and here is negative 2 square root of 3, and the positive 2 square root of 3. Right? Then we just have to look at the sign here. So f double prime, right? So f double prime, let's just look at the sign. So we can try anything smaller than negative 2 square root of 3. So like I'm going to try negative 4. So f double prime of negative 4. Right? So then look at this guy. Right? So if you plug in negative 4, you're gonna get a negative sign here, right? Negative 4 squared would be 16 minus 12, so that's positive, and the denominator is always positive, so that would be negative. So we have a negative sign here, right? Then if you try anything between negative 2 square root of 3 and 0, so I'll try negative 1 or something like that. So f double prime of negative 1. Right? So if you plug in negative 1, so that's still negative, but this becomes negative 2, and negative, negative, positive. So this is going to be positive here. Right? And we can try anything between 0 and 2 square root of 3, so we try f double prime of 1. Right? 1, you're going to get the positive here. And 1 squared minus 12 is negative here, right? So that will be negative. So we have a negative sign. All right, and the last one, we can try positive 4. And the positive for 16 minus 12 is positive, so everyone's positive, so you have that. All right, so if you want concave upward, we're looking for the positive interval here. So here between negative 2 square root of 3 and 0, and the 2 square root of 3 and on. Alright, so we say f is concave upward on the interval from negative 2 square root of 3 to 0, and also 2 square root of 3 to infinity. Right? So that those are the intervals where this function is concave upward, right? And the last question, we want to find inflection points. So you can see that the sign always changes at these points, so you have inflection points there. So we have inflection points there, right? And another inflection points there, and another inflection point there, right? So we have to find the corresponding function value. So f of 0 is easy. Plug in 0 in the original function is 0, right? And also we have to plug in plus and minus 2 square root of 3. If you do that, top is plus or minus 2 square root of 3, and the bottom would be 2 square root of 3 square, or negative, is going to give you 12 plus 4, so it's 16. So it's a plus or minus square root of 3 over 8, because we can cancel 16 and 2. Right? So we have 3 inflection points. Right? And the first one is at 0, 0. The other two would be plus or minus 2 square root of 3, and then plus or minus square root of 3 over 8. Right? So those are the, let's see, the inflection points that we're looking for. Alright, that's it. I hope that this was clear.